Okay, so I'm probably going to do at least one video, probably two, on how to graph your or sketch these sine and cosine graph waves and graphs, sine and cosine. Okay, um, so this sine and cosine waves or graphs, whatever, however you want to kind of think about them, right? So this video, I'm first just going to start with our general form and what everything means in there, right? So we have that y equals a times, we'll start with the sine, cosine, doesn't matter. All the a, b, c, d mean the same thing in both of them. So a times the sine of b times x minus c plus d. Okay, so this video, we're just going to go over what this a, b, c, and d mean, right? So A is your amplitude, okay? Amplitude is how high or low your graph would go, right? So for, I'm going to be kind of switching back between this whiteboard and the Desmos graphing online calculator. Just so that you guys can kind of see. So let's look in there just real quick. Okay, so I'm just going to start with the sine of x function, right? And so you can see here that, okay, so this sine function goes from, starts at 0, 0, highest point goes up to 1, lowest point goes down to -1, right? Now, when I change that and I say 3 times the sine of x, right? All that does is now my graph has gone from, instead of, it's the same sign, right? It's still over 0 to 2 pi. It still crosses at pi 0. But instead of going only up to 1, right, I've gone up to 3. My lowest point is now -3, okay? So that's what your amplitude does. It changes how high and low your graph will go, okay? So that one's fairly simple, right? So this is your amplitude is just how high and low your graph will go. Okay. Then you have your B. Okay, your B starts to get a little more confusing. B affects your period. Okay, so this affects the period. Okay, and so generally our basic sine and cosine functions occur. So your basic y equals sine of x and y equals cosine of x occur over the 0 to 2 pi values, right? Being your x, right? You have one cycle over 2 pi, right? Over 360 degrees, right? And if you think about that unit circle, right? We've talked about the unit circle, right? We go from 0, our sine, this is our one wave of our sine function, one wave of our cosine function, right? And so that's the same thing that happens with your graph, right? It goes from 0 to 2 pi for your sine, and it goes from 0 to 2 pi for your cosine, okay? Now, when you change that B, right, it affects your period, right? So let's look at an example and just say that y equals the sine of 3x, right? So I haven't changed anything except that now instead of having just the sine of x, now I have the sine of 3x. And so you can look at this and think about this in two different ways. The first way is to say, okay, well, that means that one cycle occurs over 2 pi over 3. Okay, right? This is your 2 pi over your b, right? So you have one cycle that occurs in a third of the way, pretty much, right? Or 1b of the way, right? The other way is to say, well, here's my b, so that means I'm going to have b cycles over that 2 pi period. Okay, right? So in this case, I would have 3 cycles of sine over a 2 pi period, over 2 pi, right? So I'm going to go back into that Desmos graph, right? I'm going to change this. This is our y equals the sine of x. And now I'm going to do y equals the sine of 3x. Okay? And so you can see that's the blue one, right? And so you can see instead of this occurring over 2 pi, right? We've got this occurring over right? 2 pi being over here, right? Okay, and so now you can kind of see, right? So instead of just having the one cycle, the red, right, occurring once over a 2 pi period, if you follow this purple or blue line, right, I can't kind of tell which one it looks like, but it's bluish purple. So you can see we have one cycle here, 2 cycles at our 4 pi over 3, and then a third cycle, right? And now we're back at our 2 pi, okay? Right? And so, again, right, we also talked about how this means that there would be one cycle occurring at 2 pi over your b, in this case being 3, right? So this is one sine wave, right? One wave. And okay, so that's what the B represents. Okay, let's go into, okay, so that is your B. Okay, and then we're going to look at the C, right? The phase shift, okay? And this has to do, this will affect where you're starting your graph, right? So your phase shift is your horizontal shift, right? Horizontal. So I'm moving on my x-axis, okay? So I'm shifting either left or right. Left or right. I'm moving my graph left or right. Okay. So for example, if I have y equals the sine of x minus pi over 4. Okay. So that means that I'm going to shift my graph plus pi over 4, right? Because, right, my c, it's x minus c. So that means I just take what that value is, right? So it's going to, instead of starting at 0, at 0, I would start, this starts at 0 plus pi over 4. Okay, so that would mean, right, my function just starts at pi over 4. And so again, if we go back into your Desmos Okay, and again, we still have that y equals the sine of x is that red function. So now we're going to look at y equals the sine of x minus pi over 4, right? And so you can see, right, it's again that bluish purple line. And instead of starting at 0, 0, right, I started at pi over 4, 0, right? And so everything, all my x values get shifted 1/4 pi, right? Pi over 4 to the right. And so since I shifted my starting point position by pi over 4, I'm going to also my ending position, right? So instead of ending at 2 pi, I end at 2 pi plus pi over 4, which apparently is 13 pi over 4. Okay, so it just shifts your function a little to the right. Okay, if this had been y equals the sine of x plus, let's say, pi over 3, oops, pi over 3, okay, so that's this black line, and you can see here, instead of shifting to the right, since I had minus, I shifted pi over 3 to the left, right? So this one, I'm going to take away this one in the middle, keep this basic sine function, but I took away the minus pi over 4 one. And so you can see, instead of starting again at 0, 0, my basic sine function, I now started at negative pi over 3, 0. And everything else stayed the same. There was just a shift, right? So instead of, again, ending at 2 pi, my function ended at 2 pi minus pi over 3. So 8 pi over 3. Or, yeah. Or no, I'm sorry. So that's 5 pi over 3. Sorry about that. Okay. So that's your phase shift. So that's your moving left or right. Okay. And then your final thing to look at when you're graphing these is your D. Your D is your vertical shift. So this one's fairly straightforward. It's just kind of at the end, right? So vertical shift. So this one is our up or down, right? So this is up or down. Okay. And so, for example, if we have y equals the sine of x plus 2, right? So what this means is that my graph will go, you go up 2 points, okay? So again, instead of my sine function having a range from -1 up to 1, my new range, when I add this, is from -1 plus d to 1 plus d, right? So in this case, it becomes -1 plus 2 to 1 plus 2. So my new range here is from 1 to 3, right? So let's go look at what that just looks like on this graphing calculator, right? So we have the y equals the sine of x plus 2, right? And so you can see, right? Our graph just stayed completely the same, except instead of starting at 0, 0, right? Your graph is starting at 0, 2, right? That's your starting point. You've moved up 2 points from your regular graph. And then that means that your highest point goes up from 1, right? So instead of being 1 as your highest point, 1 plus 2 is 3. So my highest point is now 3, and my lowest point is now 1, right? -1 plus 2 means that my lowest point is 1, okay? So that's your vertical shift. That's your D, okay? So now you put all these things together and you should be able to graph a sine or cosine function. So the next video I'm going to do will be graphing an example, okay? So hopefully that helps better. All right. Thanks. I hope this was helpful. All right.